Ladies and gentlemen, welcome to a Thursday afternoon. Today will be our first international episode, if you will, coming at me from Germany. Let's make sure I don't screw it up. Ole, how are you doing today?
I'm really good, thank you. That was close enough.
Close enough.
I always say, like with an American tongue, it's really hard to make that. So it's fine.
So I got some points, but before we get started, introduce yourself. Tell us about what you do for your day, night job, whatever.
I program. Done.
Yeah, but what do you get into?
Okay, so I'm working for DNSimple since about a year. It's my first remote job, so since it's not really a year, I'm like a big part of the job is learning how to remote. That's going pretty well.
Yeah.
It's an awesome team. I have the pleasure to work with Elixir every day, so a new language I'm really excited about. That's pretty cool.
Yeah.
And I don't know. I have a little kid. He eats a lot of time as well.
How old's your kid?
2.5.
Yeah, that's a hard age.
It is.
I can remember my son turning 3, and I was like, I thought 2s were supposed to be bad, and 3 was horrible, and then 4 was
don't
like,
tell you that.
Oh, well, here stateside, here in the States, 3 is horrible. In Germany, 3's like, I mean, you might as well just send them off to work.
No,
you send them off to work.
Yeah.
So you work at DNSimple. You guys, for those that don't know what DNSimple is, we're talking about a domain service.
Right. That's the easiest take. So we do domain management. The claim is domain management automation.
Okay.
So we do the extra bit because, GoDaddy sucks and we can do it better. So that was basically why the company was founded, like back then by Anthony. And this is still our goal. We want to provide an awesome service. And because we are, like all of us are developers and we love developers and we love automation, we have an API first approach. So everything you can do through our UI, you can also do in the API. There's something we're saying we always add it really quickly, or we try to be, always at the edge of things.
Okay.
This is really the approach. So you can do really interesting things with our API and can automate a lot of stuff.
Very cool. So I know one of the things that you cut your teeth on is the protocol stack, and
Right.
I think most developers, we get to hide behind, call fetch or, insert library here to make magical HTTP call. But
True.
In your world, you have to deal with TCP, UDP, HTTP, whatever that's there. Like,
all of it.
So let's like open the door to the sink, underneath the sink. What does that look like for, what does that look like for you guys?
Messy.
Close the sink.
So here's the thing. When you look at protocols, like 90% of what we use today is really, really old. So HTTP, like HTTP 1 is from like the early 90s. So that's really old. So they had a whole different thing in mind. DNS is even worse, air quotes. That stuff is even older. It's a big XML-based stateful TCP connection. At least the registrar side, the whole DNS protocol, like name resolving, is UDP.
Yeah.
So when you have ever like peeked into how DDoS attacks work, there's always DNS in it. So there's a lot of interesting stuff. I think the DNS protocol itself is pretty interesting, because it was optimized even back then for performance. So it's a binary protocol with UDP.
Okay.
That's pretty interesting. And maybe that gives us a good bridge, to talk another binary protocol that I'm also really excited about since a few years, and I did a lot of talks about that as well, which is HTTP 2.
Yeah. I certainly want to get into that. Before we crawl down there, I mean, what does I go to DNSimple, I get a domain. before I can go to my API and start like making it out to the world, what ends up happening from DNS's simple perspective? Like, how does your little address on the web get lit up?
Okay, so yeah, there are multiple things involved, right? So the first thing when we talk about domains that you need to understand is that you have the domain, which is the name on the internet on the one hand.
Sure.
And you need to register it. So when we talk about like thatconference.com, you need to get it from VeriSign, they own.com.
Gotcha.
So you need to go there, or we go there for you and say, that conference, we have a customer that wants to buy it. Can we have it? How much does it cost? And then we give you the price info. Then you come back to us and say, yeah, I want to buy it for that price. So we go to them and buy it for that price. But then there's no resolution. There's no DNS resolution yet.
Right.
Like up to this point, the resolution part is completely missing. So
Sure.
What happens then is that we add the domain to your account. And all the steps I'm describing now is basically a 1 or 2 click thing in the app.
Yep.
So we do like all of the hard work in the back end. And yeah, you don't have to deal with that. Then we add a few records, the ones that are necessary, like SOA and the NS records for you. And these needs to be distributed. So here we come into the resolving and DNS part. So when someone wants to look it up, the browser will go and try to map the address to an IP address. This, like how all of this process works is fairly complex because you know that saying that in computer science there are 2 hard problems, which is naming things and caching validation.
Yeah.
And this is DNS.
Yeah.
Right?
Yeah.
This is really it consists of a lot of hard problems, and especially because we want it to be fast. And this is not a thing that is like exclusively for us, but DNS is distributed. Usually it's distributed across the globe. So we have like 6 point of presence across the globe. And when you edit a record, we obviously store it in our database, but we also need to get it out to all our name servers.
Right.
So the process behind there is also fairly complex. There's a little bridge component that like receives the push notification that a new record exists. This gets pushed through all the point of presence we have out there, and then the name servers go back to the app and fetch the new set of records.
Right.
And all of this happens in a blink of an eye. So we are like in milliseconds.
Right.
Your new record is out there. And when I say this, you need to keep in mind that this doesn't say that the resolvers that are in the middle have updated their cache.
Right.
So even though we have the record out there, usually the TTL of a record is like an hour.
Sure.
You can go down to like 10 seconds, but if you want to be a nice citizen on the web, you should, put some consideration on that.
So,
and then the record is out there.
So, I mean, yeah, I have to imagine that the world that exists today, like it's just gotten, I don't want to say it's gotten out of control, but it's so big and so complicated from a global landscape that even trying to go to update the protocols or to do something better seems like it would be a monumental effort to make a change.
Right. No, that is really true. For example, there's the TCP, I think it's called Quick Open or Quick Connect. Or Fast Open, like don't ask me for the exact name, but
Sure.
This is basically a feature in TCP. So in the TCP protocol, which is fairly old and fairly stable and runs like almost all of the internet, it took them 12 years to get it in because once first everyone, like literally everyone, needs to agree on how it should look like and how it should work. So this takes a time, as you know, like even in every other company, a decision takes time. So now imagine like 12 of these big companies or more make that decision. And then like once you made the decisions, for one, there are all the operating systems that need to adopt.
Yep.
And these are maybe 2 or 3 big players. Let's say there are 2 big players, and then there's all of the Linux stuff. Luckily, TCP is part of the kernel, so it's just one that needs to adopt here.
Sure.
And then everything in the middle, like especially TCP, there's all the routing hardware, there's all the ISPs. There's so much stuff that works with TCP that like up to the point where everyone supports it, it takes a long time.
Yeah, I mean, I think we take it for granted at times, right? You turn the sink on and the water comes on, and you don't necessarily think about where it came from. And, you know,
Sure.
I mean, I do because I have a well and the power goes out and I'm getting water. But I mean, like you simplified in the beginning saying it's just a couple of clicks. And then the reality of that statement is a giant amount of shit happened globally to make that happen.
True.
And if anybody ever wants to change anything, it's like launching a satellite into space and aiming for Pluto because it's going to take a decade to make that change.
Yeah.
It's monumental infrastructure.
Okay. You can always invent new stuff.
Yeah, it just won't be used.
True, but it usually gets faster. I think this is why we see so many new things. Like when we take a look at the programming world, there's so many new frameworks. And my favorite example is JavaScript. So there's a new framework every day. Yeah. And it's because the other stuff gets hairy pretty quickly and like you don't want to touch it. And then it would be so hard to change it. So you just go ahead and make a new thing.
Yeah. I don't like it anymore. I'm just going to move on. Yeah. Just learn a whole new thing. Yeah. So you mentioned HTTP 2. What's that? We'll start there. And then how is that really different from HTTP? Mm-hmm.
So you want to start with what's that?
Yeah, what is it first?
Okay, so HTTP is basically the next version of the HTTP protocol. And when we talk about HTTP 2, the first thing that you as a developer or everyone as a developer should know is that the semantics don't change. So it's still a request response pattern, right? Okay. There's still headers. So the concept of HTTP headers is still around. But everything like underneath that basically changes. So the whole way of how information is exchanged is completely like redone from the ground up.
Okay.
So it's now a binary protocol other than a text-based protocol because it suffered from a problem called head of line blocking. Because in HTTP 1, when you make a request and then you want to make another request, but you don't have the answer for the first one, there's no way to identify the resources. So the server must respond in the same order you made the request, even though when the second one could be answered faster, like theoretically, the second one needs to wait for the first one.
Interesting.
Yeah, and this is head of line blocking, and this is basically solved with HTTP 2 on the HTTP protocol. There's still a thing as in TCP head of line blocking, because the TCP protocol takes care of ordering packets. So when a packet is lost on the internet, and this happens like all the time, TCP takes care of requesting a new version of the packet. But before it doesn't have received the missing one, it wouldn't like pass it on to the next layer. So you would still need to wait, and packet loss still like suffers from this issue.
Sure. So is HTTP or HTTP 2 a rolled out thing that's happening and we just don't know about it, or is it happening in places and in 10 years we'll see it?
Yeah, it's funny. It's funny that you mentioned it because, as I mentioned in the beginning, I did a talk or multiple talks about this, and like I was done with this talk. I didn't want to like do it anymore because I gave like 4 or 5 times. Now I'm done. And a friend of mine said, no, you should give it like up until everyone knows about it, because it is out there for 3 years now, or almost 3 years. And when I say out, it's there. It's ready to use. Well, it's ready to use since 2 years maybe. The draft was signed and that done in May 2015. And then major browsers adapted really quickly. And nowadays, every major browser supports it. I think only Opera Mini on mobile does not, but every other does.
So how do you take advantage of it?
So as someone that runs a website, the first step and just enabling it is fairly easy. You can go to your web server config like Nginx or Apache. Yep. And when you have a fairly recent version, it's basically flipping a switch. What's important to know is that you need HTTPS. And that's
Which,
fun. That's a fun story on the protocol because when they invented it, there was huge discussion in the group, in the ITF working group, if it should force HTTPS or not. And there was a huge back and forth, and they couldn't make a decision. So in the protocol, they ended up with a version that supports HTTPS and plain text. So not encrypted. Not plain text because it's still binary, but it's not encrypted.
Right.
But what happened is because all the browser vendors were really pushing towards we want this to force HTTPS, that all the browsers, all major browsers now only support the HTTPS version. So they do not support the HTTP, like non-TLS version.
Yeah.
So it's, theoretically both things exist. In practice, it's only SSL. And this is basically the biggest hurdle someone may face adopting it. But nowadays with things like Let's Encrypt it.
Yeah. I was just gonna say, you really don't have an excuse other than the fact that you were lazy and you couldn't get it done last night. Like,
right? Yeah, that's true.
It's kind of out there. You shouldn't not use it.
That is true. That's true. But then when we talk about like adopting it, there's like, I would say it's the second step you should take because you can enable it and you would maybe see a few performance gains from that because now you don't suffer from the head of line blocking anymore. Also, HTTP does header compression.
Okay.
So HTTP does header compression. That's also a pretty interesting protocol called HPAC. But anyway, so that you might gain some performance improvements, but we misused HTTP1 so hard, and we made so many workarounds in our current tech stack. Like when you take a look at all the JavaScript bundlers and things like Webpack and stuff, so we bundle all the assets together, right? And we did this because having multiple requests in HTTP1 gave you a huge penalty.
Right.
It was the thing you really should not do. Right. Now, when we take a look at HTTP2, you really should do that because all resources from a single TCP connection, which is a connection to a website basically, can be fetched in parallel. So it's really good to have that because when you split it up, you can like have finer grained caching.
Sure.
Right? And then now you sit there like with your old behavior and your old asset pipeline and is a website that is optimized for an old protocol.
That's really interesting.
On the new switch, but it wouldn't gain you that many benefits as if you would like optimize for HTTP2. And when I say optimize for HTTP2, it's really just move all the this optimizations, like inlining assets and inlining images. You shouldn't do that. And you shouldn't even do that in the first place. You just everyone just did that because it was faster in HTTP1.
That is super, super interesting. I never really thought about it.
Yeah. It would gain you, I think, a lot of benefits.
So you basically have to install the new unwebpack library that's coming out that's going to run after Webpack runs to undo what Webpack did because you don't know
basically.
You don't know how your React site ended up in Webpack in the first place, so you need a library to undo the thing.
It's been years since I really peeked into all of that. Maybe you can have a loader that just undo whatever the other loaders did. I don't know. That's pretty interesting.
It'll be interesting to see like the years to come and the pendulum kind of slide back the other way and especially with CDNs and everything as readily accessible as they are today.
That's true.
It all up together is kind of weird.
And when you take a look at the big websites like Twitter, Facebook, Google, well, we should count out Google for a second because they do a whole different beast. But Twitter was one of the very early adopters of HTTP2. So they have it out for very long. I don't know if they adjusted their asset pipeline already, but now you see more and more people moving. And what's interesting is obviously the big player moves first. Have the resources to do that, obviously, but on the other hand, they have so much traffic that whenever they can shave a few bytes off of their bill, like they pay for every byte transferred, right?
Sure.
So when they can shave off a few of the bytes, they will benefit. And as I said, like headers are compressed. Generally, you have like less stuff transferred. You can have like a compression thing. So they have an incentive. They have a really incentive doing so.
Yeah, totally. So what do you feel like we as web developers kind of like what should we be paying more attention to the stacks underneath? I mean, obviously the HTTP2 is something we should kind of readily know about.
Mm-hmm.
But I mean, so what do we do?
I think, it's a tough question, right? I mean, there's so many people that claim themselves as like full stack developers, and then you can just ask them to implement the next kernel patch in Linux, and then you see where it goes. I don't like this term, because it basically like unveils the issue you just mentioned, right? You can't know everything.
Yeah.
And like, as I just mentioned, it's been a while since I looked into JavaScript. So I was more in the front end and regular web dev role before, and now I'm just transitioning more away from that, not knowing the latest, hottest stuff, and just knowing more about the backend side. Yeah. I think what's important for everyone that like deals with the web is to know at least the bits they touch and they're affected by. So you may not know like the nitty gritties of TCP, but I think every web developer should know about HTTP. I think this is really where I would say I would draw a border or draw a line. But maybe that's just me because, you know, I like
to you're in it.
That,
right.
But it has, and this is what I said, it has a few things where every developer would really benefit, every website would really benefit from. To know about this and to optimize for it and push their operations team, for example, to move to HTTP2 because it has a lot of performance gains, and you know, performance is something we all care about.
Yeah, and quite honestly, free performance, right? I mean, it's some configuration changes at the minimum to start using.
Right.
Yeah.
Right. And then when you have it like a CDN or something, it's probably just flipping a switch.
Right.
It just gives you for free.
You had mentioned DNSimple has an API for everything that you do in the UI. Where do you find applications using that? I mean, I think of myself every time I need to make a DNS change, I gotta like relearn what I set up in the first place. But where do you see people programming to DNSimple?
Mm-hmm. So I think the biggest consumer of our APIs are people that are building website builders. Okay. You know, it's like a meta game. So when you offer something that sells websites, you don't want to deal with all the domain stuff yourself.
Sure.
So if you have a website builder of any sort, and we have a few specialized ones, you know, they have a specialized version of a website builder. Or just marketing campaigns where you can have your own domain. They implement our API.
I got
and
you.
Then they can use all of this, you know, listing the domains. You can even buy a domain via the API. This is what they need, really. And you can make changes to DNS.
Sure.
Yeah.
That's cool. I want to shift gears a little bit because you mentioned it at first.
Sure.
You're a remote worker. As everybody can see, I am in my house. I have done the remote thing for a long time, both to a company in Bulgaria and then along in stateside. So I want to ask you, being somebody from Germany, you're working remotely back. DNSimple, as I assume, is headquartered here in the U.S.
We don't have, well, yes and no. We are globally distributed.
Okay.
And there's like 50% of us on the US, yes.
Okay. So what do you feel like has been your biggest challenge as being somebody who's working remote?
Oh, that's a tough question. So being really honest, I think motivation and keeping yourself on track. So when I was dreaming about going remote, everyone was telling, you know, when you work at home, your home is your workplace, and it's hard to differentiate. I was like, whatever, I can deal with that. I did this when I was in the office. No. And, you know, I can tell you the same thing, and everyone that like listens to us now is like, no, I can deal with that. And maybe you can.
No.
I just just couldn't. I was really bad at this. I still am. When I'm at home, when I stay at home, when I decide to stay at home for a day, it is more exhausting for me to start doing. And once I start doing, it's good. Once I get in the flow, it's good. It's working. And this is really what it was the good part, that I learned a lot about myself. Yeah. This is something I couldn't have just phrased like a year ago, and now I know this. Yeah. And when I, feel that I have a hard task to tackle, I leave the house and I go to a co-working space.
Sure.
Because I know this helps me to get productive.
Sure. And
all the remote thing really helped. In the first place, helped me to learn a lot about myself.
Yeah. Yeah, I can, we built the house that we're in, and it was purpose built to have a home office. I was already working at home, and I like to say we don't have a faux office. We have an actual office that is, the lighting and network jacks and proper desks and all that kind of good stuff. But, the transition time from, room to room, which is the commute, be it 6 stairs, is mind bending in the sense that you never really get to decompress. So if you were in a hard problem, you're still in a hard problem by the time you get upstairs. If you were, upset, you're still going to be upset. There's no transition time. And that can be super hard.
I'm sitting in the corner of my living room, and I totally know this. Like when the family is around and I'm working and then I'm done working, it's just, one step. And I totally know what you're saying. Like when you don't have time to decompress. And this is why I also love going out.
Yeah.
Because then I just have a commute, and I can choose how long it is. So I can go to a co-working space that's downtown, which is for me like a 20-minute, or I can go to my favorite cafe, which is like a 10-minute bike ride.
Yeah.
So that's really cool.
Yeah. Yeah. The other thing that I've always found hard, and I'm curious if you have as well, is there gets to be these moments where you don't leave, or you feel guilty based on the peers that you work with. And so instead of working maybe a 40-hour week, you end up working a 90-hour week, and maybe you haven't showered, and you just like this grind went on, and you're like, holy cow, it's Friday. And, I need to go smell some fresh air, cause I haven't left. And I don't think others recognize the pressures when you're not around. I don't know.
Right. Especially when you're remote and you don't see the others. And like when I was working in the office, I was getting paid for just being present. Yeah. I mean, my former boss would disagree, and obviously this is not how I handled it. But when you were present, everyone was, you're there. And this is the good and the bad part of being remote. Like results count. Right. I can be online and offline in Slack, and nobody gives a shit.
Yeah.
But if I open up DPR or make the commit or like do the customer support or whatever my task is when I ship this, then people see that.
Yeah.
And I totally know the feeling when you don't ship it, or when you get the feeling you don't deliver, or you do a spike in a branch and then it doesn't turn out. It feels like a wasted day because nobody see that you did something.
Right.
So, and this probably could us bring to the last point that's like super important, is communication, right?
Yeah.
So when remote, like communication and good communication and the way how you communicate is really important.
Yeah.
I got a feeling I got a lot better in just saying things and phrasing out things and just speak from my heart.
Yeah. Yeah, I like the results driven. That is certainly that certainly rings true. And communication, both. I mean, I typically always have a webcam on.
Okay, interesting.
Yeah, I mean, I like it depends on time zones and things like that. But to not be able to see somebody, not only does it keep me accountable, because it's easy to be like, this is a great meeting, and just kind of go back to doing work, because back to the results oriented thing. Like if the thing doesn't get done, like what's the epic weight of this meeting? Granted, you can say no to meetings, whatnot, but there's times where you just have to do it. If you have the webcam on, you have to be present in it. And if you don't, you could just, whatever, just bang that code out and put yourself on mute and go away.
Yeah, that's true.
But I certainly try to keep the webcam on as much as I can.
But we could do another hour about remote meetings.
Yes, we could.
The most fun things happen in remote meetings. I mean, it's hilarious. It just starts with the fact that no one, like in every meeting that has more than 5 attendees, someone doesn't get the audio straight.
Well, so I will qualify that though. I think that people who do it all the time, there's no issue. I mean, I ran a company where we were all remote. We never had any issues. Like, we had all the right tools. We didn't have like the enterprise, like, use the thing, and then like that thing never works. Like, we all had the right tool for the right job. It was always installed. You would go into Slack and, you know, click your thing and it would come open and do whatever you needed to do. But you're right. The ones who it's not native to, it's always like, is anybody there? You're like, yeah, I've been here for 5 minutes. I really know what you want me to say.
I did not want to blame the people. It's all also, I mean, we had, as I said, we distributed so in different countries, and there's always someone that has the most shittiest connection.
Oh yeah.
So my boss for a long time was working from the middle of nowhere in France, and he had like donkeys carrying packages or packets. So he had really slow internet, and it's always fun. There's always something going on. Someone dropping off. I don't know, children running in the room where you have the meeting, or it's like there's always something happening, and I like that. It's way more life friendly to work that way.
Yeah,
human. Yeah, totally.
There was a great video going around last year sometime of it was a parody on the working remote or the remote meeting, and you would see like the packet, the audio going out, and the guy's like, you know, running out the door with this other thing. I'll have to find it. It was super fantastic.
Yeah, nice. It's
right,
fun.
We're at time. Before we go, I want to just say thank you to you. I know that you have not just for being on here. I know that you are working some side hustle with putting up a site to share slides. I know that you go out and speak across the world. I know that the flight from the U.S. to Germany is not a short one. I've done it to Munich many times. So I want to say, you know, thank you to you for sharing, being part of the community and everything. That's just
thank you for having me.
And
thank you for doing all the stuff you do, like that conference. Pretty cool. I've been there a few years ago, like 5 years ago.
A number of years ago,
yeah, 5 years ago. It's been,
and it's changed quite a bit since you've been there.
Okay, cool.
Last question of the day. Knowing everything we talked about, what would be your kind of piece of advice that you would want to leave with any of the developers out there?
Be nice.
Oh, I love it.
Be nice. Be kind. Be human. That's it. Just tech is just tech, but be nice to other humans. Love each other.
Oh God, I love that. I absolutely love that. I am in your camp with that one all the way.
Cool.
Well, listen, Ole, thank you for the time. I know it is late there, and you need to have that beverage before the sun starts coming back up.
Yeah. Well, sun is like 6 hours away.
Yeah, I know. It's late there. All right, sir. Well, thank you very much, and look forward to talking to you again.
Yeah. Thank you, and goodbye.